Welcome in the third section of our course. In this section, we'll be analyzing data using Hive and Pig, so two big data tools, two descriptive languages that gives us an ability to perform MapReduce queries in a declarative way. So we'll be introducing Pig, introducing Hive, and also using an HQL query language. And this is a first video in which there will be an introduction to Pig tool. So we'll see what the Apache Pig is, example of Pig job, and why to use Pig. We will answer that question as well. So what is Apache Pig? Pig is a high-level scripting language that is used with Apache Hadoop. It works by describing data analysis problems as data flows. Pig is complete in that you can do all the required data manipulation in Apache Hadoop with Pig. So all tools that are available using MapReduce API also are translated to Pig. Pig code could be invoked by many languages like JRuby, Jython and Java. Also, you can execute your scripts in other languages. When choosing new tool, the first question is when to use it. So for example, good use case for Pig is the ETL job. So when we need to extract some data, transform it in a specific way and load it to the other data source. Also, Pig can ingest data from files, streams or user-defined function. Pig can store the results in the Hadoop data system. So let's look at the Pig flow. So we are at the beginning of the graph. So we have a Pig Latin scripts and we want to write that script, and also we want to understand what will happen every step when we will execute our script against Pig engine. So firstly, the Pig scripts are translated into a series of MapReduce jobs that are run on the Apache Hadoop cluster. As a part of the translation in the Pig, Pig interpreter does perform optimization to speed execution on Apache Hadoop. So firstly, Pig is parsing your query, compiles it to the bytecode, it optimizes your query because some predicates like for example filter could be pushed up, and execute the plan using MapReduce engine. And also it can save data to HDFS. Let's say that we are given a CSV file with such record. So every record represents a movie. So first we have a title of movie, year of production, rating, and number of rates. And we want to create a MapReduce job that will filter movies that have rating above 4.0. So there is a couple of solutions that we can employ here, but this is a very good use case for Pig because this is a fairly simple problem, and also we want to leverage the MapReduce and Hadoop cluster, but we can use Pig for that specific problem. So let's write a Pig script for that. To start Pig, we need to type pig-x local. It will execute our machine on the local. If you want to execute it against the cluster, we will pass some cluster information. Then let's load that file using the load command from Pig. So we will be loading it using load, as we can see here. We need to pass a full path to that specific CSV file. Then we are using the Pig storage, and this is a comma separated file, and we also can give a schema for that specific dataset. So there is an ID, name, year, rating and duration. And the rating is a field that we are interested in. First, we need to dump our movies because we need to load them to the cluster. We can see that we load them and then everything is printed out here. So we have the ID, title, and also finally we also have rating, like 3.1 is here as we can see. So let's filter out movies that had rating bigger than 4.0. We can use a filter predicate, this is from the Pig language as well, from movies because we called our dataset movies, by rating. We need to cast it to the float, and the condition is that greater than 4.0. We are assigning it to the movies greater than 4. And this is executed in a no time because this is lazy, same as with Apache Spark. So not until we will create some action that will dump that data, that predicate will not be executed. So let's execute action, and action will be actually saving that data to some location. So let's call it movie greater than 4 by packed. And it will store our data, movies greater than 4 that we assigned here, into that specific path. So let's run a job and we can see that everything succeeded. So let's look at the path. We can see that new directory appeared here, movies greater than 4 by pack. And inside of it, we will have the part file. We can see that this is dumped in such specific schema that is specific to pig, but we can see that all movies that reside here had rating greater than 4, like for 3, for 1, for 5, and so on and so on. So we were able to analyze big file. We can use it, of course, for the file that has gigabytes of space, and leverage cluster and pig map reduce engine.